Hey everybody! Starting today through the next 5 weeks, I'll be making videos as part of a winter series for the R programming language. Through these videos, we'll be steadily growing our R programming knowledge and expertise, with such work culminating in a final project on February 11th in celebration of International Day of Women and Girls in Science. For the project, we'll be analyzing data published by the U.S. Census Bureau from 2019 regarding trends in female employment in various STEM and STEM-related fields. Today's video will cover setting up and familiarizing ourselves with the R Studio environment, going over basic R syntax and introducing vectors. Future videos will go over matrices, factors, data frames, lists, and manipulating and visualizing data from tables using tidyverse tools like ggplot and dplyr. But before we dive further into such topics, let's first understand what the R programming language is and what makes it so unique. R is a language and environment for statistical computing and graphics. One of R's strengths is the ability to create amazingly detailed plots through simple lines of code, compressing large amounts of data into easily readable and quickly accessible graphs. It's important to note that R's main strengths comes from its packages, such as the tidyverse toolkit mentioned earlier. We'll be using such packages to help us manipulate and analyze larger, more complicated datasets. But for the purposes of today's video, we will be getting comfortable with the R language first through smaller datasets. To begin, we need to have the R Studio environment accessible on our devices. To do so, you can log into your browser and go to rstudio.com, and you can either download the IDE onto your computer from the following website or register for a free cloud account accessible online. I'm going to be accessing my development environment online, but either method will work. On the top right, we will select a new R project and wait for our workspace to be loaded. When our project is first deployed, we'll see 3 main tabs already open. Our console, where we'll be typing in our code, files, which will show the files already loaded into our project and where our larger datasets will be uploaded in future videos, and our environment, which shows what variables are stored in our program. We will see as we write our code that this box will update to showcase what new variables, packages, and objects we have added to our environment. For now, I'm going to minimize my Environment and Files tab so that we have more space to see our console, but note that you can always access these tabs again in the future. Above, I'm going to assign a name for our project based on the chapter that we're in. Now let's explore the basic programming syntax of R. Similar to Python, R makes use of the pound sign to add comments, so that you and fellow programmers can notate what you write and understand what another's R code is doing. However, something unique to R is the definition of variables. R uses a backwards arrow, like so, to demonstrate a variable's value being assigned to it. Note that a variable is especially important in a statistical programming language like R. Through variables, you can call on the value or object stored within it to manipulate it later. In R, the data type of the following variable would be called a numeric. Note, though, that even if a decimal value is included in this definition, the variable would still be a numeric. This differs from the programming language of Java, where the definitions of numbers are differentiated between whole numbers and decimal values, the use of integers and double respectively, but this is not the same case in R. Also, quick aside, if we reopen our Environment tab, we can see that the variables we just defined are now loaded here as well. Boolean values are known as logicals in R, but you use the same true and false values seen in other programming languages. Just note that they must be defined in all capital letters. And for the last data type in R, characters not only refers to individual letters, but also strings of letters and full sentences. If you ever want to double check what the data type of a variable is, you can always use the class function to do so. For R, if you ever want to print out the output of a line of code, you don't have to use any special statements like print. Writing it on the line and pressing enter will showcase the output to the same console. However, it is still okay to use print in these situations and you'll still get the same output. The following are the symbols used when you want to manipulate numeric values, either through their variable names or the numerics themselves as shown. The lists provided are basic arithmetic functions you can do with R. But it's important to note that last operation, modulo, refers to the remainder of the division of 2 numbers. You can always take the output of such operations and assign it back to a variable, as shown here. To compare the values of numerics, you can use the following operations. These will output a logical true or false-based value based on what you're comparing. For example, mod_1 == mod_2 would print true, because for each variable, you're finding the remainder of dividing 7 by 3. However, mod_1 is not equal to mod_2 prints false, because these two variables are the same. Now that we understand basic R programming syntax, we can start to explore more complex topics, like vectors. Vectors are one-dimension arrays that can hold data in the form of the various types we have just shown, such as numerics, logicals, and characters. To create a vector, you use the combine function, as shown here. A cool component of vectors is that you can name the individual positions of the array, similar to how you would do in a one-dimensional table. For example, let's say that we're looking at data for the amount of people employed in STEM fields. We create a vector called CS_jobs and assign it to a specific occupation in the CS industry and the amount of people that work in that field. Note here that while the second term should technically be a numeric type, vectors do not allow you to have multiple types defined within it. We'll need to use lists in order to have a numeric alongside a character, which we will see in future videos. According to the U.S. Census Bureau, there are 35,193 computer and information research scientists in the U.S. in 2019. However, if we were to print out the vector we just made, we really don't know what such information is telling us. Are there 35,000 CS research scientists in the US or in the world? Does the number represent the total amount of research scientists in the population, or is it only for a certain group of people? We can clarify such data using the function names. Note that names can be used on all vector types, including characters, logicals, and numerics. Another advantage of being able to use such names is that we can call an element of a vector based on these names. For example, calling occupation for CS jobs will return the value stored at that position, which is the name of the occupation, computer and information research scientists. If you didn't have the names assigned for these positions, you can always use the number of the position to call on such value. In R, the first index of an array starts at 1, not 0, like other programming languages. Therefore, calling the following will print out the exact same thing as before. Finally, for our numeric vectors, you can do calculations with them just as you did for basic numeric variables. When you sum two vectors in R, it takes the element-wise sum. Therefore, all the following statements are completely equivalent. You can also do the calculations with variables that represent each vector, and add them together and assign back to a new variable. However, let's say instead of the element-wise sum of the vector, we want the sum of all the values inside that vector. Luckily, we have the sum function to do so. For example, the following results would be 21, because 3 plus 7 plus 11 equals 21. Other important functions to know are mean, median, max, and minimum that performs basically what their names state. You can also use the comparison symbols on numeric vectors, as we saw with the numeric variables. It will return true or false based on the comparison of each variable with their respective variable in the other vector. This is what we just used with the double equal sign to show that the various ways of summing two vectors are the same. I hope this video helps to provide an introduction to the R programming language and the programming environment, as well as an overview of what vectors are and how they are used. Next week, we will expand on vectors and look at two-dimensional arrays called matrices, along with more complicated datasets seen in data frames.